scroll at the bottom of the TV. I don't know. These 20 schools are dismissing their kids 2 hours early today because of the heat. I guess because they don't have air conditioning. Seems like crazy. If you could take out the slope homework, we had some problems that we were calculating slope on Friday. We're also deciding if lines rise, fall, or vertical or horizontal based off of just knowing what their slope would be. Are there questions that you would like to talk about or over together from the homework involving the slope of lines? Will, did you sleep okay last night? Yeah. Catch up on your sleep over the weekend? No questions? Slope's pretty easy. So this morning through Remind, if you're signed up for Remind, you should have gotten a text or email, depending how you have it set up, with the assignment sheet for the week. So it's on Remind. You click on it, you can download it to your iPad, or you can just click on the assignment sheet every day. It's up to you. It's also posted to Google Classroom. So it'll be those 2 locations, and then it's on the backboard there, where it says the section 2.3, so the honors algebra 2 class. So those would be the locations that you can find the assignments for the week. Every Monday morning, I will post a new assignment sheet to Remind in Google Classroom. So every week there'll be a new one posted. And just a reminder, this Friday you'll have a quiz on sections 2.1 to 2.4. We'll do a mini little review on Thursday. We are going to do like some new notes on Thursday, a handful of new notes, and then like a tiny review for the quiz on Friday. It's not really a formal worksheet that you'll have, but the material, like we've talked about, evaluating functions and slope. Today we're going to look at graphing lines. Tomorrow we're going to write equations of lines. So it's pretty basic pre-algebra, algebra 1 material that we're going over. The second half of the chapter is a little more interesting. So that's why Friday's quiz, just a minimal review that will kind of just give a little refresher on Thursday. So if you'll pass forward your homework then, if you don't have any questions, remember at the top, give me a smiley face, a neutral face, a frowny face. And then tonight's assignment, I talked about those homework presentation problems. So I'm going to ask for 3 volunteers at the end of class, 3 different people to present 3 problems tomorrow from the homework assigned today. And you would just do that problem on a separate piece of paper. You'll come up, throw it underneath my document camera, and then just a little explanation as to how you solve the problem. So I'm going to start that tomorrow. And prior to the end of the period, after we go through some notes, I'll ask for 3 separate people to do each of one of those problems that are on the board there. So we'll start that tomorrow. And those are 2 per semester. So you have to do 2 this semester, 2 next semester. They're 4 points each, class participation points. All right, so I think today's notes are going to be really easy and straightforward. We're going to talk about graphing a line, slope-intercept, graphing a line using x and y intercepts. That would be page 11 in your notes packet, section 2-3. So the first vocab term we have here is a parent function, and we'll talk about parent functions with each type of function and graph that we look at. Anybody know what a parent function is? Kind of weird that we say like functions have parents. So a parent function is the most basic form of a function. in a family of functions. So functions have parents. Functions are also considered families. A family is just the same type of equation that you're working with. So a line is considered a family of functions. The parent function would be the basic form of a line, and we're going to look at that right underneath. But we will talk about quadratic functions. That's another family of functions, and we'll look at the parent function, and then all the different types of ways that we can kind of change that. So the parent function is the basic one. Once you start adding numbers to it, then it becomes a little more interesting, and it's related to the parent function, but the line moves, it changes. So underneath, it says that the parent function of a linear group, that would be our line, is just the form y equals x. So it has no extra numbers added in front of the x, it has no extra numbers added or subtracted behind the x. That's what makes it a parent function. It's the most basic form. There isn't anything extra added to it. It says the graph is shown. So it has a y-intercept at the origin. It begins at the origin. And then its slope is just 1 over 1. Rise over run 1 over 1. Because there's just a 1 in front of the x. There's not an extra number in front of that. So in general, a parent function of a graph is the y-coordinate, let's say, not the parent function, a y-intercept down here. There we go. Of the graph is the y-coordinate of a point where the graph crosses the y-axis. So we have the slope being in the front, the y-intercept in this case is just 0 because nothing's added or subtracted behind the x. And that y-intercept is wherever the graph crosses the y-axis. So underneath, there's a couple of little reminders about how to graph when you have this parent function, this linear function, family of functions. My air plays slow. So we have the standard form of the equation, and then we also have the x-intercept. And we'll talk about this slope. There we go. All right, so slope-intercept form. Who remembers slope-intercept form? Holly, you remember it? So what's the slope-intercept form?
Y equals mx plus b.
Yeah, so Abby said y equals mx plus b. Come on, there we go. Abby, do you remember what the letters stand for?
The m is the slope. The b is the y-intercept.
So the slope-intercept form of a line is the equation y equals mx plus b. And as she said, the m is the slope, the b value represents the y-intercept, the graph crosses the y-axis. So to graph in slope-intercept form, just a little refresher, write the equation in y equals mx plus b form. And graphing using slope-intercept form, it needs to be in slope-intercept form by solving for the y. So if it's not in y equals, we need to get the problem to be in y equals. The second step, we'll plot the y-intercept. You begin with b. So b, begin, that's where you start your graph. So you begin with the letter b, that's the y-intercept of the graph. It's the point 0, comma b, where the line crosses the y-axis. The third step says to identify the slope, which is the m. And use it to plot a second point on the line, a third point on the line. We usually plot a couple and not just two. Slope represents the movement of the graph. Is it moving up? Is it moving down? So the movement of the graph would be the slope. And then the last one would be to connect a line through the 2 points, multiple points, depending on how much space we have. So you begin with slope, you move, or you begin with B, you move with the slope. And if you flip the page, there's a simple little example. So graph the equation in slope-intercept form. Y equals mx plus b. The b value is 1. The slope is -3 over 2. So you begin with b, you move with the slope. So you're starting up on the y-axis at +1. And then the slope has a negative in front, it's -3 over 2. Connor, can you explain how you're moving with the slope?
You go down 3 and to the right 2.
Yeah. So that negative needs to be assigned to either the top or the bottom of the fraction. It doesn't go to both because a negative divided by a negative makes a positive. So assign it to either the top or the bottom, and that's how you're moving then with your slope. So from the y-intercept, which was 1, we're going down 3 and right 2. And we usually plot a couple of points depending on how much we can get graphed on here. So we have space for 3 points. You can plot 3. And then we want to connect our points with a line. Hopefully yours is a better line than mine. So that'll be slope-intercept form. Any questions? So slope-intercept form is y equals mx plus b. It gives you the slope and the y-intercept. That's why it's called slope-intercept form. The second type of equation that we can work with when we're talking about linear equations is called standard form. You'll find that most equations that we work with can be written 2 different ways, and they'll get 2 different names. So the slope-intercept form is when it's in y equals mx plus b. Does anybody know what standard form looks like when you have a line? How is it different from y equals mx plus b? Awesome. So ax plus by equals c. The a, b, and c are just numbers. So they're not extra variables thrown in the problem, just like m and b in slope-intercept form are just numbers. But you're going to see it just set up a little differently. The x and the y are on one side, a number is going to be on the other side of the graph. Generally, when it's in standard form, we try and think of a different way to graph it. And we can graph equations or functions in standard form using the x-intercept and also the y-intercept. So we said a y-intercept was where the graph crossed the y-axis. What's an x-intercept? Odette?
Across the x-axis.
Yeah. So the x-intercept is where the graph crosses the x-axis. And its ordered pair is whatever your x is, comma, the 0. If it's crossing the x-axis, it doesn't have a y value because you're not moving up and down. You're on the x-axis. Y is equal to 0. So x might be 10, x might be 5, it could be -3. But the y value will always be 0 because you're finding an x-intercept. You're finding a place where the graph crosses the x-axis. So we're also going to graph using standard form because sometimes it's easier if you're given a specific equation. The way the equation looks kind of decides or helps you decide which form you want to graph. So step 1 says write the equation in standard form if needed. I would say if it's not in standard form, don't use standard form. If it says y equals, use slope-intercept form. So based off of the way your equation looks would be how you determine which form you want to use. The second step says identify the x-intercept by letting y equal 0 and solving for x. So we're going to have this equation. Essentially, we're eliminated one of the variables because we're making the y value 0 and solving for the remaining 0, or the remaining x value. Use the x-intercept to plot the point where the line crosses the x-axis. So we're going to take our equation. We're not maneuvering it, changing anything, moving anything. We're keeping it in the form that it's in most cases. But we're replacing the y with the zeros so that we can find the x-intercept. The third step then is the opposite. Let's identify the y-intercept by letting the x be 0 and solving for the y. So essentially you're doing the opposite so that you can find the other variable. Use the y-intercept to plot the point where the line crosses the y-axis. This time we will only have 2 points because you're going to have a point on the x-axis, you're going to have a point on the y-axis. And then you're going to play connect the dots, just connecting those 2 points. So you see that this is in standard form. It doesn't look like y equals mx plus b. We have 2x plus 3y equals 12. Instead of automatically thinking in your brain, let's just switch it so that it's in y equals mx plus b form, we can solve it or graph it in standard form as well by finding the x and the y-intercept. So we're not changing anything. We're not going to rearrange the variables. We're going to keep them as they are. So no rearranging of variables when it's in standard form. So just a little reminder, to get an x-intercept, we're going to let the y equal 0. So in our equation, we're solving for x. So we have 2x. The y is 0 if we're finding an x-intercept. So it's pretty straightforward because the y is becoming 0. That means the y is gone from the equation. And Julian, if we solve for x, what do you get?
6.
Yeah, x is equal to 6. Now it wants us to write this as an ordered pair. And that's something throughout the year that we're really going to try and work on. If it's a point on the graph, it needs to be written as a point that we would plot on your graph. So this ordered pair is 6, 0. X equals 6 is a solution. 6, 0 is an ordered pair that you plot on your graph. So 1, 2, 3, 4, 5, 6. Here is our x-intercept. So if we want to find the y-intercept, that's when we do the opposite by making the x 0. So 2 times 0 plus 3y equals 12. And Julian, what would y be then?
4.
Yeah. So y is 4. We plug the 0 in for x. We have a solution of y being 4. And then again, connect your 2 points. Still have a line, doesn't change the graph, just changes the way we graph it. So instead of using the y-intercept and moving with the slope, we're just finding the x and the y-intercept, those 2 ordered pairs where they cross the x and the y-axis. Just a different way of thinking about graphing. Probably not the common way to use, but if it's in that form, ax plus by equals c, you might as well try and graph it in the form you're given. Any questions? So if you flip it over, really short day of notes. I believe it's just these 2 examples on the next page. Kind of reviewing the difference between a vertical and a horizontal line. So it says horizontal lines. The graph of y equals c is the horizontal line through blank. So think, if you have a horizontal line, what is it going to cross over? Which axis was a horizontal line cross over?
The y-axis.
The y-axis. So our point is going to be 0, c. Whatever the y is equal to is the only point you have that crosses the y-axis. There isn't really a slope. It's not moving up and down. So then a vertical line is the one that's going up and down, and it would be the opposite. This graph is in the form x equals. It's a vertical line that crosses through the point C, comma 0. There are two crazy words that we've kind of created to help you remember these things, and whether they help or not, kind of up to you to decide. But we have the word hoy and the word vux, and they're really not words. Hoy represents the fact that we have a horizontal line, so that tells me the type of line I have. The 0 is the slope of that line. And the y tells me that it's in y equals 4. Everybody mixes up horizontal and vertical lines, no matter what class you're in. Whether you're in my pre-algebra 2 class, you're in a regular algebra 2 class, you're in honors trig and pre-calc. You know my honors trig and pre-calc kids still mess up whether it's horizontal or vertical. They always want to do the opposite. So a horizontal line should have a slope of 0. It should be in y equals 4. That's what the hoy stands for. The vux then talks about your vertical line having a slope that's undefined. U represents an undefined slope. It's vertical. It's not moving left and right, therefore your slope is undefined. And it's an x equals 4. If that helps you, if you remember those two crazy words, hoy and vux, when you're graphing vertical and horizontal lines, you graph them correctly, awesome. Just trying to give you an extra piece to help you remember which way those lines go. So the last two graphs we have underneath here says graph the horizontal and vertical line. So y equals is a horizontal line that crosses through the point 0, comma, whatever that number is, and it's a -1 here. Because the slope is also 0. It's not moving up and down, it's just moving left and right. So you're going to go to the point, in this case -1, and you're just drawing a horizontal line through the y value of -1. And that's it. It has no movement besides moving left or right, because there's not a rise or a fall in the line. The slope is 0. The second one says graph x equals 2, so when it's x equals, it's a vertical line that goes through the point 2, 0, so whatever the number is over there is where your point would be, connecting the x-axis. So x equals 2, we now have a vertical line that has an undefined slope going through the x value of 2. Questions? So I'm going to hand out your homework. You actually have 15 minutes to get a really big head start on it. There are a handful of graphs that you're going to be working on. Some of them is just working on finding x and y intercepts. I would say once you start to work on the graphing questions, make sure you kind of look at the way the equation is written and try and decide should you use slope-intercept form, or maybe try the standard form based off of the way the problem is written. But don't always revert to slope-intercept. Try both of them based off of the way the equation is given to you. And then when you get this, look at 14, 26, and then 31 and 32. Those are kind of grouped together because it's a two-part problem. They go together. So you're completing 2 through 26 even. And then 28 to 31, the 4-word problems on the back. So would somebody like to be a brave volunteer to try number 14 for tomorrow? That one you're finding the x and the y intercept based off of the equation. Jillian, you'll try it? Awesome. Alright, so if you flip the page, look at number 26. It's a graphing problem. Somebody like to try number 26 for tomorrow? Mackenzie, you'll try it? And then the last two, 30 and 31, they're kind of paired together because they're a little word problem that goes together. Any takers to try 30 and 31 tomorrow to present it in front of the class? Nobody likes doing word problems. Okay, we'll just do those two, and if you decide you want to try 30 and 31, let me know tomorrow or later on. But you have until 8:18, so about what, 14 minutes? Class goes to 8:18. The graphs, obviously, you can put on here. The x and the y-intercept problems. Please put those on a separate piece of paper. Show me a little bit of work. Don't just say x equals 5 and y equals 3. You also have the solutions to this if you kept the worksheet from yesterday. How many of you passed it forward? Let's see. Looks like some of you may have passed it forward. I'll try and get these back to you tomorrow morning during homeroom so you can check your answers. But if you didn't pass the worksheet forward yesterday, or this morning, you should still have those answers, and they're on the back of the worksheet from the slope problem.